Okay, let's have a go at applications of the second derivative. We have a position function in terms of t, where t is in seconds on the domain 0 to 6, and the first thing we're going to solve is the velocity function. Alright, so velocity is found by deriving x, and this is a product rule scenario, so I'm going to call this one u and this one v. The product rule is vu dash plus uv dash. If you use a different variation of that, that's fine. And so v is e to the power negative 1/2 t. The derivative of u is going to be 8. U is 8t, and the derivative of v is negative 1/2 e to the power negative 1/2 t. Alright, let me tidy this up a little bit. I've got 8 e to the power negative 1/2 t. A positive with a negative is negative. 8 times 1/2 is 4, so 4t e to the negative 1/2 t. There's our velocity function. Part 2 asks for our acceleration function. So acceleration is going to be the derivative of velocity. And this part should be easy enough, but over here I've got another product rule scenario. So over here, deriving 8e to the power negative 1/2 t, I get 8 times negative 1/2 times e to the power negative 1/2 t. And then I'm going to add on the derivative of this part. And I'm going to call this one u and this side v. Alright. So we have vu dash again plus uv dash. 8 times negative 1/2 is negative 4, e to the negative 1/2 t plus, right. The v is e to the power negative 1/2 t. Derivative of u is negative 4, include that negative, plus u, which is negative 4t, times by the derivative of v, which is negative 1/2 e to the negative 1/2 t. Okay, let's tidy this up. This part should stay the same. Then I have negative 4 e to the power negative 1/2 t, and over here I have negative 4 e to the power negative 1/2 t. They're the same. I can actually combine these two and say this is negative 8. I have negative 8 of them. Alright, working this part now. I have a negative times a negative, which is positive. 4 times 1/2 is 2. E to the power negative 1/2 t. Okay, so I think I'm missing a t there. That t should go here. And that's my acceleration function. Alright, part B says, find the initial speed. Okay, well, speed is using the velocity function, so we're solving for the initial. Initial means when time is 0. The initial speed is solving for velocity when t is 0. So, go to our velocity function, which is this one here. And we're going to substitute 0 for t. That's what it looks like. 8e to the power negative 1/2 times 0, take away 4 times 0, e to the power negative 1/2 times 0. Okay. Well, I've got 0 times negative 1/2, which just comes out to be 0. So I've got 8, e to the power 0 is just 1. 8 times 1. Take away 0 times all of this is just going to come out to be 0. So it looks like I've only got an 8 meters per second. Okay. Part C. When is this object at rest? Okay, well, it's at rest when the velocity is 0. Not at time 0, but when the velocity is equal to 0. So let's take this velocity function, 8e to the power negative 1/2 t, take away 4 t times e to the power negative 1/2 t, and make this function equal to 0. Okay, I have an 8 and a 4 there, which means I can divide everything by 4, and I get 2e to the negative 1/2 t, take away t times e to the power negative 1/2 t. And I can factorize e now. Like so. And the null factor law says either this product is equal to the 0 or this product is equal to the 0. So let's write that. We have e to the power negative 1/2 t, and hopefully you already know that a function of e cannot equal 0. That's not possible. But over here we have t is equal to 2 seconds. So at 2 seconds we have a velocity that is 0. It's at rest. And then we need to answer the question, what is its position? Alright, I'm going to work over here now. The position means we're going to have to use the position function x when time is 2. So just substitute 2 in for time, and we get 8 times 2 e to the power negative 1/2 times 2 is equal to 16 times e to the power negative 1, which is equal to 16 on e. Okay, and that is its position. So position is in meters from the origin. And if you wanted to know what value that is, e is a number 2.7. It's close to 3. We can round up to 3 just to get an idea of how much this is. So if 15 divided by 3 is 5, 16 is a little bit larger than 15. E is a little bit smaller than 3. So this is going to be a number larger than 5, closer to 6. Okay, so it's approximately 6 meters from the origin. Alright, going to part D now, find when the acceleration is greater than 0. So find the acceleration function. It's right here. And we have to find when this is greater than 0. Okay, well, in order for us to do that, we're going to find when the acceleration is equal to 0, and then we'll test either side of those values for when it's positive. Here we go. We have negative 8 e to the power negative 1/2 t plus 2 t times e to the power negative 1/2 t. Make that equal to 0. Alright, so that's the acceleration function. I have an 8 and a 2, so I can divide everything by 2, and I get negative 4 e to the negative 1/2 t plus t e to the power negative 1/2 t is equal to 0. Factorizing e's, I get e to the power negative 1/2 t times by negative 4 plus t is equal to 0. Again, this e function cannot equal to 0 using the null factor law, but t is equal to 4. In other words, the acceleration is 0 at t is equal to 4. Now, the domain is 0 to 6. At 4 we have 0 acceleration, which means to the left and to the right of 4 seconds, we could have a positive acceleration. Okay, and we don't know which one it is. So, what we'll do is, we'll test a value to the left of the 4. I'm going to use 1 second. And then we'll test a value to the right of t equals 4, like 5. And we'll see which one comes out to be positive, and then we'll draw our conclusion. So, our acceleration function again is here, plugging in t equals 1, and we get negative 8 e to the power negative 1 half times 1 plus 2 times 1 e to the power negative 1/2 times 1. And this comes out to be negative 8 plus 2 is negative 6 e to the negative 1/2. And that is obviously a negative number. It's negative, so it didn't fit the bill. We're going to have to test the right-hand side now of t equals 4. All right, so here we go. Testing for t equals 5. We have negative 8 times e to the power negative 1/2 times 5 is going to be negative 5 on 2 plus 2 times 5, which is 10 e to the power negative 5 on 2. And this comes out to be negative 8 plus 10 is 2 e to the negative 5 on 2. And that's obviously a positive number. This is greater than 0. We can conclude that the acceleration is positive when t is from between 4 and 6 seconds. So acceleration is greater than 0 is positive when t is between 4 and 6 seconds. Oh, well done for getting through all that. Good luck on those questions.